Hello guys, welcome back to my channel, Maison African Motives. In this platform, we shall be focusing on the question paper, which was actually written in 2004. That is for paper one. It is actually 2004 paper, the one that we have got here. So we shall see how we are supposed to attempt this typical question paper that we have got here in a space of time that we have got, and also we shall try by best to just quickly rush through this and see what we have got. All right, so let's see guys, the first part of the question paper. Remember your instructions, read everything on the instructions. Make sure that you read all the instructions before you attempt the question paper. Okay, so that was our first question, and also neither mathematical tables, no slide rules, no calculators may be used in this paper, which means they are not allowed in this paper. All right, so that is it, guys. You are not allowed to use any of these. Okay, so the first part we are given in this case, all right, okay, so this is what you're given. Write down the number 0,04 188. That is the number that you're given. Correct to 3 decimal places. Let me just put a brighter one. Okay, so that is to 3 decimal places. That is the first item that we are given, to 3 decimal places. So 3 decimal places, that means we have to count 3 digits after the comma. That is from the number that we have got, that is 0,004188. All right, so that is the first one, 1, 2, 3. So which means this one here cannot change this 4 because it's less than 5. And also take note, guys, there's a lot of wind today. It's very, very windy. So that is why there's a lot of background noise there. Okay, so it's going to be 0,04. This one cannot change this 4, so it is going to be 4 like that. Okay, then on number item 2, that is to 2 significant figures. So significant figures, remember I told you these are actually whole numbers. You're referring to whole numbers. So the first whole number that we have is this 4. So you're going to count, this is 1, this is 2. So this number, the next number 8, is going to change this 1 into 2. So it is going to be 0,0042. So that is what you're going to have in this case. All right, then let's see another part that we are given. Let's just try to move a little bit here. All right, so the other part that we are given is to write the given number 3,57 times 10 to the power minus 3 in ordinary form. So how do we write this number in ordinary form? So remember that if you're multiplying by 10 to the power of minus 3, it simply means we are going to move 3 commas to the left. So this is 3,57, not 8 but 5,7 here. Right. Okay. So that's a 5 here, not 8 here. This is a 5. Okay, so this is what we had. So here we are multiplying by 10 to the power minus 3. This is a negative power that we are given, so which means we're going to move 3 commas to the left. Okay, so from the number that we are given, if we are to move 3 commas to the left from this value, we're going to have 1, 2, 3. So these are the commas that you have moved. So in place of this, you are going to put in the zeros in place of these groups. So here we are going to put a 0 in place of this, also a 0 here. And since your comma is at this point, so there's another 0 here. So it is going to be 0,00357. So that is what you're going to have in ordinary form. That was the question there. All right, so let's just try and see another part of the question. All right, here we give, so that was it, guys. And also take note, you're actually filling in, so you have to answer exactly where you're given. Okay, here we are given on this item 2A to simplify. So that is what we have got. So remember, for us to simplify, we can actually cancel out because here we are multiplying. So we can just cancel out here, guys. 2 into 2, that is 1. 2 into 4 here, that is 2. 7 into 7 cancels, and 7 here cancels. We also have y here into y squared. We are going to remain with y here. Okay, we have got also x. Yeah, there's x here, this x, and this x can cancel. We also have this t here, the t here, and the t squared. So this is going to be a t. All right, there we are left with the y and y here, which is going to be y squared. So if we cancel this y and this y here, we are going to cancel 2 of them here. So it is going to, we are going to remain with a y here. And do we have anything? We are just left with x squared. So there's nothing that we can do. So on top, we are just left with x squared. Over in the bottom here, we're just going to write this as 2ty or 2yt. Okay, just I don't know the best way for you to write this, but that is what you're going to have in this case. Okay, b, we are given that v is equal to u plus a. V is equivalent to u plus at. It's a formula that you are given. Actually, for those who are doing a physics, you understand this much formula. So you're given to calculate the value of u of v. Sorry, we here the value of v given the value of u, a, and t. So how do I simplify this? I simply have to substitute the values that I'm given. So in this case, our item 1, v is going to be u, which is a 0 here. So that's 0 plus at. Our a is 3,5, so it's going to be 3,5 times t, which is our t is a 4 in this case. Okay, so that is 0 plus 3,5 times 4, 4 times 5, that is 20. We have 2 here. 4 times 3, which is 12, plus 2, that is going to give us 14. So it is going to be 14. And we have 1 decimal place, so it is going to be 14,0 there. So 14,0 is same as what? Is same as 14. So our v will be 14. So that is the case, guys. Take note on your multiplication. Multiply properly, because this is paper 1. Multiply this properly. Okay. So that is the case. So on item 2, now we are given to find the value of t. So we can substitute into the formula what we are given. We are given v here. So remember your formula, we are given v. So in this case, our v is minus 7. So minus 7 is equal to u. In this case, our u is 8. So it's going to be 8 times 80. This is plus here. And our a is minus 3. So it is going to be minus 3t, like this. Okay, so this is what you're going to have in this case. All right, so which means we are going to remain with something like minus 7 is equal to 8 plus and minus. Take note, a plus and a minus, that is a minus, so it is going to be minus 3t. So you're now back to your original equations. How you solve your equations, you can choose to take this 8 to the left hand side so that it can be a negative. So we know that minus 7 minus 8 is going to give us minus 15. So minus 15 will be equal to minus 3t. So we can divide by minus 3 here. So if we divide, this is going to be t is equal to, cancel this negative and negative, 3 into 15, which is going to give us a 5. So that is the value of t that we're going to obtain in this case. All right, so that was actually it. And yes, just 3 marks, as you can see, 1 1 1 1, which is 3 marks, which is fair question. Yeah, it's a fair question actually. So let's see on number 3. You're now given number 3 to calculate the exact value of 0, so these ones we just have to multiply them. Let's just multiply it here. 0,072 multiplied to 0,4. Okay, so this is 0,4. Okay, let's multiply, guys. Take note here, you have to work with 4, so it's 4 times 2, which is 8. 4 times 7, we know this is 28. So it's going to be 28. We write the 2 here. All right, 4 times 0 here, that's a 0 plus this 2, so it is going to be 2. And 4 times 0 here, that's a 0. Okay, so how many decimal places? Because this 0 is not going to affect anything. So we've got 1 here, 2, 3, 4. So we've got 4 decimal places. That means we must have 4 digits after the comma. 1, 2, 3, 4. So which means our answer is going to be 0, 0,0288, because we must have 4 digits after the comma. Okay, so that was it on this part. On item B, we are now given to simplify or to evaluate this and give our answer as a common fraction. So as you know, guys, whenever you're simplifying fractions, we have to work with the LCM of these numbers. So this is what we're going to have. Okay, so we need the LCM of 7, 3, and 42, okay, which is in this case, it's a 42, okay? Then we can divide 42, divide by 7. This is going to give us something like 6, okay? Then 6 times 2. So take note, whatever that you get, you multiply. So you said 6, then you multiply by 2, plus 3 here. So it's 42, divide by 3, which is going to give us something like 14. That is 14. So 14 times 2. Okay, minus 42. So it's 42 here, divide by this 42. That's a 1. So it's 1 times 5. That is what you are supposed to do actually. So 6 times 2, which is 12, plus 14 times 2, which is 28, minus 1 times 5, which is 5, if we are not mistaken there. And this is over 42. So if you are to add this, add 12 and 28 according to your board mass, we have to start by adding. So it's going to be 14 minus 5, everything over 42. And if you are to subtract 40 minus 5, that is 35. So this is 35 over 42. Can we reduce this? Yeah, let's see. We've got 7. Yeah, by 7 into 35, that is 5. 7 into 42, that is 6. Yeah, we can reduce this. Okay, so it's going to be 5 over 6, just like that. Okay. Then on C, we are given to express 0,341 as a percentage. So as a percentage, you simply multiply by 100%. Whether it's a decimal or not, as long you are given that it's a percentage, multiply by what? By 100%. So multiplying by 100, we simply move 2 commas to the right, and this is 34,1%. So that is what you're going to have in this case. Okay, just like that, guys, you are done. Okay, so that was actually again 3 marks. As you can see, 1, 1, 1, 1 there. So these are 3 marks. And we are given on question 4. Okay, that is our question for them. Okay. That is actually an application of parallel lines. As you can see, these are parallel lines. This line is parallel to this line, also parallel to this line. And we're given this is angles of 30 degrees. So we're asked also to calculate the angles that we are given there. So not to waste much time, let's just try to, okay, let me just select this so that we can see the first question. So the first question we are given to calculate the angle BCD, okay, which is BCD, this angle here. This is the angle that you're asked to calculate here. All right. So guys, remember these are parallel lines, and I can even make adjustment here. Guys, you see now the way. Okay, I can make adjustment like this. Okay, something of this nature, where I know this is 30 degrees, and since this angle and this angle create a Z, as you can see, we are having a Z here. So this is going to be 30 degrees also. But remember that the whole of this angle previously was 90 degrees, the whole of this angle. It was 90 degrees. So 90 minus 30, I'm going to have the remaining angle here, which is going to be 60 degrees, okay? This 60 here and this angle that you're talking about, they are creating a Z. So which means this is 60 Z, that is alternate angles like this. So this angle and this angle, they are the same. So that is 60 and 60. So which means your BCD is 60 degrees in this case. All right, that is what we had. And let's see another question, CBQ. Okay, CBQ. Let's get back to CBQ. So CBQ, that is C here, B, CBQ. Okay, so this is our CBQ, this angle here, the one that I'm indicating here, this is your CBQ. So what is the relationship between this angle here and this angle of 60 degrees? These are the ones which form a what? A C. So these are called co-interior angles. They add up to 180. This angle and this angle, they add up to 180. So which means to find this angle, we are going to simply subtract 60 from what? 60 from 180 degrees. So this is 60 here, which is going to give us 120 degrees. So this is 120 degrees there. That is the angle that you're going to get from your co-interior angles. So we say this is going to be 120 degrees, just like that. All right. So that was the case there. Let's see another part. 3 marks again for this. Okay, then on number 5, we are given in this case if you are given the inequality of x, which is greater than or equal to -1. So it means our values of x, they are going to start from -1 up to 4. Okay, so I'm going to just indicate 3 values which are important on this set of values from -1 up to what? From -1 up to 4. I'm going to work with this value, the minimum value, and 0, and also 4. These are the values that I'm going to work with. Okay, here we are given -9 up to -6. So as you can see here, we are just in between negative values. So I'm going to work with -9 and -6. There is no a 0 here because we are still on the negative side. Okay, remember your number line is like this. This is a 0 here, -1, and this is 1. So -6 is somewhere here, -9 is somewhere here. So which means these two, they do not have anything to do with a 0 there. But -1 to 4, as you can see, we have got -1, maybe 4 is somewhere here. So which means 0 is going to be included in between. That is why I had to include that 0 there. Okay, so I hope we are together on this part. Okay. Let's see another part that we are given here. Do this. I want to remove this part, guys. All right, so I think this software is new to me. I was using another software in this one. I'm still learning how to actually apply it, but okay, let's hope it is going to be fine. With time, we're going to learn and learn and learn as much as we can. Okay, so the first part, like I was saying, that these are the values that you take. You don't work with everything here. So the first question is for you to calculate here the greatest value of y minus x. So we need y minus what? Y minus x. So these are the values of x, and these are the values of y here. So which value can we take from these two values and we subtract to any of these 3 values here, and we are going to have what? The greatest value. Which one can we take? So it's a trial and error question that you have to do. As for me, let's try this one. If we take -6, this one, -6 minus the value of y, and we take this -1 like this, let's see what you're going to have, because minus and minus is what? It's a plus. So it is going to be -6 plus 1, which is -5. I think that is the one that is going to give us the greatest value in this case. You can try other values, but you're going to see this one is the one that is going to give you the greater. What I'm trying to say is that let's say you decided to take this one, y, which is -9, and you say -9 minus x, your x, you take another value. So you have to any of the values. So here we're going to have -9 plus 1, which is -8. So it's a trial and error. As you can see, -8 is smaller than -5. Remember, when you are referring to negative values, the closer the value is to 0, that is how bigger that value is. Okay, so this one is going to give us the maximum. So you can try, guys, and see which one is giving you the maximum, if there is any, so that you can just refer to it in the comment section. Let us know about that value that you have obtained, so that it can help us. Okay, on B, we are given to find the least possible value. This one is the least possible value that now you are supposed to find of x squared minus y squared. So like I said, it's a trial and error, but on your trial and error, don't just try everything. you are trying these three values here, and on y, you are trying these two values. So which one can give us the minimum? Okay, I'm going to use this one, 0 squared for x, because x, there's a 0 here. So I'm going to use 0 squared minus the value of y. For me to take note, guys, if a number is bigger, like a 100 like this, and it has got a negative, and if a number is smaller like this one, the bigger that it is, it becomes the least because of being a negative, not because of the value to say it's a 1. No, it's because of the negative. So we are going to target the one that is going to give us the bigger value with a negative. So definitely on y here, the one that can give us a bigger value is what? Is -9. Because if I square this -9 here, because it's y squared, if I square this, it is going to give us a positive 81, and this one will be 0 squared, which is 0 minus 9 squared is -9 times -9. So definitely it's going to give us what? A positive 81. But when we subtract now 0 minus 81, we are going to obtain what? -81, which makes it a bigger value in terms of the digit. But because of this negative, it becomes the least of the values because it has got what? A negative. Are we getting this, the sense there? So that is actually the consideration, or that was what you're supposed to attempt this type of a question. Okay, let's see the other part there. We are given on number 6 to simplify, to evaluate the value of 1/2 to the exponent of 0 plus 2 to the exponent of 4. So here, guys, any number to the power of 0, you know that is 1. So this one is going to give us 1 plus 2 to the power of 4, that is 2 times 2 times 2 times 2, 4 times, and you're going to obtain 16. So 1 plus 16, that is 17. Okay, then solve the equation x to the exponent of 3/2, which is equal to 27. How can we solve this? As for this one, remember, if you are given an exponent, you have to find the inverse of this exponent. The inverse of 3/2 is simply 1 over that number. 3/2 is simply 1/3/2 like this, which is going to give you 2/3. Or just know that if you 3/2, you just interchange these numbers. That is the inverse. And that is the one that you're going to use. So remember, for you to remove this exponent, you raise to the exponent of the inverse. Okay, you're going to raise this to the exponent of the inverse, which is 2/3, and also this 27 to the exponent of 2/3, because this one is a 1 here. So these two can cancel, and you're going to obtain a 1 here. So it's x to the exponent of 1, which is equal to 27 to the exponent of 2/3. Okay, so x here is to the exponent of 1 is x. And we know from our laws of exponents that x to the exponent of a over b is same as what? The bit root of x to the exponent of a, everything to the exponent of a. So that is the case here. We are going to have the cube root of 27 and everything here to the exponent of 2. And that is, okay, let's just remove this part. It's not giving us a z not, we need an equal sign. Okay, so it's because of like it tries to autocorrect everything, like it knows how to correct. So this is going to be x, which is equal to the cube root of 27, which is 3. The number that multiplies itself 3 times to give us 27 is 3 to the exponent of 2. X is going to give us 3 times 3, which is 9. Remember, 3 squared, that is 3 times 3, which is going to give us a 9 there. So that is the value of x that we are going to have in this case. And yeah, I think it's pretty clear, guys. Let's see another part there. So everything is pretty clear there, and as you can see. Okay, so on number 7, we are now given, in this case, to simplify, it's actually a triangle that we have got. And let's see if it is going to give us something here. What are we given actually from this right angle triangle? Okay, so we're given the information here. We've got 90 degrees and the size of 3. The first question is to calculate QR. QR, this one. Q to R, this one. Okay. Okay, so that one we can apply even Pythagoras theorem. I think it's best way. using Pythagoras theorem here, because we are given PR and QP, and it's a right angle triangle, and you want the third side. So you can apply Pythagoras theorem, which states that h squared is equal to a squared plus b squared. So in this case, the hypotenuse is the one that you want to calculate, which is QR, the one that is opposite to the bigger side. So it's 3 squared plus 4 squared. So they just take the shorter sides. So 3 squared, that is 9, plus 4 squared, which is 16. If you add this, this is 25. This is QR squared. So to find QR, remember, we have to introduce the square root both sides. So QR is 5 centimeters in this case. So this is 5 centimeters here. All right, so that is what we actually had in this case. Okay. Let's see another part of the question. Write down the value of cos CQR. Okay, cos CQR. Let's see where our CQR is. Where is our CQR? Okay, this is what we want here. Cos CQR, that is this angle here, CQR, this one, from C to Q to R. But the question needs us to find cos of that angle. Okay, that is cos CQR. So where are we going to obtain this cos? Okay, what we know, guys, is that there is a great relationship between these two angles, the acute angle and the obtuse angle. This angle that I'm indicating here, which is PQR, this angle, and the one of CQR. This is an acute angle here, and this one is an obtuse angle. Okay, we know that because it's in a right angle triangle, you can't have an obtuse angle in a right angle triangle. So definitely this becomes acute, and this one becomes the obtuse angle. And what we know is that the cos of the obtuse angle, is equal to the negative cos of the acute angle. That is the relationship that you must know. The cos of the obtuse angle is equal to minus cos of the acute angle. So in this case, I want to find the cos of CQR, which is an obtuse angle. This one is an obtuse angle. So what am I going to do? I'm going to simply find the cos with a negative of the acute angle. So it is going to be minus cos of the acute angle, which is this one, your acute angle. And according to this acute angle, it's in a right angled triangle. So which means I can apply those mnemonics from our trigonometry. We know that from your SOHCAHTOA, from our SOHCAHTOA here, from our SOHCAHTOA, this is cos, which is adjacent over the hypotenuse. So it's going to be minus the adjacent over the hypotenuse, because now this is an acute angle. So you can apply this ratio, but with a negative from this concept. So it's minus adjacent. According to this angle, this is your adjacent, which is 4. So it's negative 4 over the hypotenuse, which it does not change, which is 5. So that is our cos CQR. Okay, so that is the relationship between cos of an acute angle and the cos of an obtuse angle, which goes on to even it is not just about cos, even tan, even sine. But what you must know is that for tan and the cos, those are the ones which carry a negative, but sine, it remains as a positive. What am I trying to say? Let me just write it here so that we can at least have it at once. If it is tan again, we are saying that tan of an obtuse angle is equal to negative tan of an acute angle. So it's equal to negative tan of an acute angle. All right. If it is sine, sine is the same. Sine of an obtuse angle is equal to sine of an acute angle. There we don't apply any negative, you just leave it like that. Okay, so that was the case there. So let us see the other question, guys. Let us see. Okay, given that QC is equal to half of QP. Calculate the area of triangle CQR. Okay, let us start by this part where we are given that QC is equal to half of PR. Okay, if they are saying QC, this is our QC here. Let's see if it is going to work this side. Okay, this is our QC. And we are given that this QC that we have is equal to half of what? Half of PQ. Is that so? Okay. Okay. Let's see the question. Half of PQ. So this is half of PQ exactly. So if this is half of PQ, what does this part mean, guys? This is half of PQ. What does this part mean? Which means we can actually find our QC first. Let us start by finding our QC, because from P to Q, we have got the length here. From P to Q, as you can see, it's what? It's 4 centimeters. So it is going to be half of 4 centimeters. That is half of 4. And this is going to give us 2 centimeters. So it means from Q to C here, from Q to C, that is 2 centimeters. All right. Now I want us to check something that is very, 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 very important. I think if I can remove this part, it can help us a lot. The eraser part of this software, guys, is getting me somewhere. I don't know why, but on the other softwares, it seems like it's much, much easier to erase. Or maybe it's me who is failing to use it. Guys, these softwares, you have to learn them. You have to learn how to use them and so forth and so forth. But okay, let me just put it here so that we can understand what is happening here. All right. Okay. Okay, it's just too slow, but it will be working, but it will be just like too slow. Okay, so we were saying we have determined the length of what? Of CQ. Now the question is for us to calculate the area of triangle CQR. Okay, so what is going to be the area of this triangle CQR? So how are we going to find the area of this triangle CQR? This is our triangle CQR, this one that I'm indicating here. So this is our triangle CQR. And if we are to cross-check this triangle, actually, it's a non-right angle triangle. As you can see, it's a non-right angle triangle. And we know that area of a non-right angle triangle is given by this formula. Area is equivalent to half AB sine theta or sine C. So that is the area of the given triangle. And A and B are the sides which are creating the angle, which means we are talking of this 2 and this 5. A and B are there. So you can write area is equal to half of 2 times 5. But we do not have this sign. And the theta that we are talking about is this angle Q. This is the theta that we are referring to. So we need sine of this angle. So where are we going to obtain sine of this angle, which is CQR? That is where we now have to go back here on this relationship that I was talking about, that the sine of the obtuse angle is equal to the sine of the acute angle. So therefore, we can even find this because we have the acute angle on the other side here. And we know that according to sine, from our sine SOHCAHTOA, sine is opposite over hypotenuse. So it's going to be opposite over hypotenuse in this case. And according to this, your opposite is 3. So it's going to be 3 over hypotenuse, which is 5, which is this longer side. So we have got sine of the acute angle. And we are saying the sine of the obtuse angle and that of the acute angle, they are the same. So we are just going to multiply by that value, which is 3 over 5. Take note, we are saying this is sine 3 sine acute, which is 3 over 5. Do not write it as sine 3 over 5. No, it is now 3 over 5 like that. Okay, so that means you can be able to cancel out, guys, here 2 and 2 can cancel out, 5 and 5 can cancel out. So therefore, our area is going to be 3. That is going to be our final answer. We're just left with what? With the 3 here. So therefore, our area is going to be 3 square centimeters. So that was the case there. Okay. So I don't know, guys, if you had any other method and you obtained the same answer just like the one we have here, let me know. Let me know so that we will be able to identify other formulas which help other students. Okay. On number 8, we are given f of x on A, there we are given f of x, which is equivalent to 3x plus 2. Find f of minus 2. So, guys, I told you whenever you're dealing with functions, f of minus 2 simply means in place of x, we are going to substitute minus 2. So it's 3 times minus 2 plus 2. That is what you're going to have. 3 times minus 2, which is minus 6 plus 2. And if you add this, we are going to obtain -4. Okay. So that was the case. And on number B, we are given to solve the equation. So here, let us just try to write this 5 as a fraction, which is 5 over what? 5 over 1. So you can actually clear fractions here because we've got 2, 1, and 3, which are the denominators. So you can find the LCM, which is in this case is 6. So the LCM has to multiply each and every term. So here we are going to multiply this by 6. Multiply this by 6, multiply this by 6. So 2 into 6, that is 3. 3 times m, which is 3m. Here it's 1 into 6, which is 6. 6 times 5, which is 30, which is equal to 3 into 6, which is 2. 2 times 4, 2 times 2, sorry, which is 4m. Okay, so you can collect like terms. So in this case, 30 is equal to 4m minus 3m. So 30 is equal to 4 minus 3, which is m. So that is the value of m. So therefore, m is equal to 30, just like that. Okay, so that's what we had in this case. As you can see, guys, it was pretty clear. Okay, so let's see another part. On number 9, we are now asked to solve the equation. That is, these are simultaneous equations. So for us to solve this, we can choose any method that we want. So in this case, guys, I'm just going to use substitution. Like we've been working with elimination and so forth. So today, let us just try to use a substitution method. All right, that is substitution there. Okay, so I've got two equations. I'm just going to name this my equation 1 and this my equation 2. All right, so from my equation 1 here, I'm just going to work from equation 1. From equation 1, okay, let us make m to be the subject here because the substitution method, okay? I'm going to make m to be the subject. So m is going to be equal to, I'm going to transpose this to the right-hand side, and it's going to give us 13 minus 2n. So this is 13 minus 2n, okay? So I now have this as like a third equation because I have decided to formulate another equation from this. So using substitution method, this is what you're going to do. You substitute this m, which is 13 minus 3 minus 2n, into m of the second equation, this one. So your answer, so you're going to have something like this: 2 into m. So substitute here, substitute equation 3 into equation 2. That is what I'm trying to say here. All right, so you're going to substitute into equation 2. That is a 2m. So in place of m now, you're going to substitute this m, which is 13 minus 2n, okay, minus 3n, which is equal to 5, just like that. Okay, so let's expand brackets, guys. 2 times 13, that is 26. 2 times minus 2, which is minus 4n, minus 3n is equal to 5. Okay, okay. This is 5, guys. Okay, this is 5 here, not the other way. Okay, so it seems like my 5 is very, very ugly. I don't know how. I don't know why. So this is 5. Let me try it. Okay, so let's collect like terms here. It's going to be 26 minus 4 minus 3, which is minus 7n, is going to give us a 5 in this case. So you can transpose this whatever way. So you can be left with minus 7n, which is equal to transpose this to the other side of the equation is going to be negative 26. So 5 minus 26, that is a negative 21. Just like 26 minus 25 is 21, then you take the sign of the bigger number, which is a minus in this case. So if we divide by minus 7, by minus 7, we can cancel this, and n is going to be 3. So n is 3 in this case. That is what you're obtaining. So to find m, we are going back here where we already have our m as the change of subject. So you can simply write m is 13 minus 2n. So m is going to be 13 minus 2 times n. We have obtained the value of n here, which is 2, which is 3, sorry. So this is a 3 here. So it's going to be 13 minus 2 times 3, which is 6. So 13 minus 6, which is a 5. All right, so this is a 5 here. So that's what you're going to have. So therefore, our m in this case is a 5, or n in this case is a 3. Okay, so that's what we had, and you'll be having on your question paper, remember where to write your answers here. So that is where you're going to write your answers. In this case, we said our m was what? Our m was 5. Yeah, that was 5, and our n was 3. So as you can see, guys, 3 marks for that. You're done with the simultaneous equations, something that you can actually obtain all the marks there. Okay, on number 10, we are now given to factorize. The first part, factorize. Okay, let's see what we have here. I think it's just a direct factorization here. It's just a direct, because if you have to cross-check here, let's start with the numbers. We have got 6, 4, and 2. 2 is common here. Okay, let's move on to h. We've got h squared, we've got h here, we've got h here. H is common, so you can factor out h. Okay, and that is the only part that is common. So let's divide 6 divided by 2, that is 3. H squared divided by h, that is h. Minus 4 divided by 2, that is minus 2. That is minus 2, not the way that. Okay, so this one is going to give us minus 2 here. H and H will cancel, so it's going to be minus 2p actually. Okay, plus, there's a plus here. So 2h and 2h will cancel, so definitely you're going to remain with the q. Okay, so I think that's what you're going to have. So you just cross-check, guys, if you're having any other part, but that is what we had there. Okay, evaluate these are matrices. So as you can see, matrices, guys, remember, for you to know the answer, like how it is supposed to be, you can take the order of the first matrix. The first matrix here is 1, 2. We have got 2 rows in this case and 1 column. So it's a 2 by 1 matrix, which is multiplying. You have got 1 row and 2 columns. So remember, if these two are the same, it means multiplication is possible, and your answer is going to be a 2 by 2 matrix. Okay, so here we've got row by column, so it's 2 times 4, which is 8. We move on to this row and this column here, so it's 2 times minus 7, which is minus 14. So you're done on this part. We move on to another part here. This row here with 3, so it's 3 times this column of 4, 3 times 4, which is 12. 3 times minus 7, which is minus 21. Like that, you're done. Okay, so this was a tempting question because some of us here, okay, let's hope you are not going to do that. Okay, on number 11, you are now asked to find the smallest whole number by which 756 can be multiplied so that the product will be a perfect square. Okay, we talked about this type of equation actually when we said a perfect square is supposed to be written in terms of what? Even exponent. It must have even exponents. Or even powers. That is what we refer as what? As a perfect square. So in this case, for us to see that, we have to write this 756 as what? As a product of its prime factors. That is what we have to do. Guys, this software does not detect my, oh, what am I doing now? I have to remove this, guys. I have to remove this. Yeah, I don't know why it detects my 8, my 5 as if it's an 8. I actually don't know. How is that so? This software is detecting my 5 as if it's an 8, or it's the way that I'm writing. I don't know. Okay, anyways, so let us see this and 7, 5, 6 in this case. Okay, the only way for us to know the exponents, we have to write this as what? As a product of its prime factors. So in this case, we have to start by the smaller value, which is in this case, it's a 2. So 2 into 756, 2 into 7, that is into 6, that is 3, remainder 1 here, into 15, which is going to be 7 into 14, and that's the remainder 1, into 16, which is 8. Okay, then we move on to again 2 into 3 here, that is a 1, remainder 1, into 17, which is 8, into 16, and there's a remainder 1, which is going to give us 9. So as you can see, 2 is no longer possible for us to use. We move on to 3, 3 into 18, that is 6, 3 into 9 here, that is 3. We divide again by 3, which is 21 here. 3 into 21, that is 7, 7 into 7, that is 1. Okay, so 756 as a product of its prime factors is 2 times 2, which is 2 squared, 3 times 3 times 3, which is 3 to the exponent of 3, and we only have 1, 7, so it's 7 to the exponent of 1, like this. Okay, so this is our 756 as a product of its prime factors, and as you can see, it's not in terms of even exponents, because we said if it is a perfect square, it must have even exponent. Like this one is an even exponent, but this one it's not an even exponent, and this one is not an even exponent. So how can we have an even exponent here? Okay, this is a 3. The moment we just add a 1 like this, it becomes an even number because it will be 4. If we add a 1 like this, it becomes an even because it will be 2. But guys, adding 3 plus 1 to give us a 4, we are adding an exponent. Yeah, it's an exponent that we are talking about, because we said it must have even powers, that is even power or even exponent. So we added a 1 here, not like on the number, but on the exponent. So actually the number that we used here in order for us to add this, it was 3 to the exponent of 1. That is the number that you used. This is the number that you used. And here it's 7 to the exponent of 1. So you're going to multiply by 7 to the exponent of. So here we have to adjust this number by 7 to the exponent of 1, because we know that this is what we had before. If you multiply by 7 to the exponent of 1, you are going to add the exponent, isn't it? So that is what we have here, because we are saying it's going to be 1 plus 1. The same with this part, we had 3 to the exponent of 3 before. Now we are saying if we multiply by 3 to the exponent of 1, that is the only way for us to add this exponent, so that it will be 3 plus 1. So this is the number that was adjusted, the number that you multiplied with, so that it becomes an even exponent. Okay, so here there's nothing that you're going to do because it's already an even number. So that is why we have to work from what? From these values. Okay, so this is going to be 3 times 7, which is 21. So 21 was the smallest whole number that we used to multiply this 256. That was the smallest number that was used there. Okay, so I hope you understand this. If not, we're going to meet again in another question and so forth. As you can see, these questions, they do repeat. So we are going to have another question like this. As we explain more questions, you might be able to get us. Okay, number 12, that is actually circle geometry there, your circle geometry. Okay, we are given that this is y, and center O, and given the diameter and an angle of y. Find in its simplest form, that is the question here. Find in its simplest form an expression in terms of y. So whatever that we have, it must have the value of y. So what expression is that one? For the first angle, it's B or C. Okay, so that is B or C, the first angle here. So let us locate our B or C here. B or C in terms of what? In terms of y. Okay, so this is our B or C here. Sorry guys, let me put it here. Okay, so this is B or C, this angle here. That is the one that we need in terms of what? In terms of y. So what is happening? Remember from your circle geometry, this is a chord, our chord here, BC here, and we know that angle subtended by the what? By the chord. If we are having an angle that is being subtended at the circumference and another one at the center like this, angle at the center is going to be twice this one at the at the circumference. So this is going to be 2y in this case. So that is our angle there. So angle at the center is twice angle at the circumference, guys, from your theorems there. Okay. So that means in this case, we are going to have 2y in this case in place of BOC. That is a 2y degrees. Okay. Then what about OBC? OBC, let's locate our angle here, OBC. Okay, so if we are to cross-check here, this is OB to C, this angle here, this is your OBC. Okay, there's one thing that we can actually note here. From O to C, you've got a radius. From O to B, that's a radius here. And we know that from the radii concept, radius is actually the same. So this triangle becomes an isosceles triangle where we know that base angles will be equal. These angles which are opposite, the sides that are equal. So these two, they'll be equal also. So that means these angles, they are equal. Angle B is equal to angle C. So how can we find these two equal angles? We simply have to subtract 108, 2y here from 180 degrees. Then whatever that we get, we have to divide by 2. Of which from from your expressions there, you can't subtract 180 like these two. We can't subtract. Why? Because these are unlike terms. So what we can only do is to separate this 180 degrees divide by 2 minus 2y degrees divide by 2. So 2 into 180, that is 90, minus 2 into 2 is going to cancel, and you're going to remain with y, everything like that degrees. So it's going to be 90 minus y degrees. Okay, so that is the angle that we are going to have on OBC, which is this one, because we are saying these two, they are the same. So if this is 90 minus y here, it means also this is 90 minus y, something like that. Okay, so that's what we had. Let's move on to another question. On number 13, we are given, these are logarithms. Guys, remember your logarithm. Whenever you're dealing with logarithms, you have to know or to understand the laws of logarithms, all right? So the first part, we are given log 5, which is 0.699. And the other thing that I want you to note, I want you to tip you guys so that you know if you're in exam, when you are given logarithms like this one, it's a logarithm of 5 in base 10. You must also know that these logarithms, you must bear in mind logarithm of 1 in base 10. Remember, I told you that logarithm of 1 in base 10 is a 0. Logarithm of 10 in base 10 is equal to 1. Logarithm of 100 in base 10 is equal to 2. You must know these logarithms. We know that just the number of zeros is your answer here. Put 1 0 is 1. 2 here is 2. So if it is 1,000, it's going to be 3. These ones, they don't even give you, they know that you must know these ones by your head. So they will not give you these values, but they will expect you to use them. They don't give you, but they will expect you to use them. Okay, let's start with 125. The first part is to evaluate log 125. So in this case, we have to expand this number in terms of these numbers, either 100, 10, 1, or this 5, okay? So in this case, it was easier for us to just use 125 as 5 times 5 times 5, which is 5 to the exponent of 3, 5 times 5 times 5, like this. 5 times 5 is 25, 25 times 5 is 125. And from our laws of logarithms, we know that from this law, P log M, we know that P log M is equivalent or is the same as writing this as what? As log M to the exponent of P. So this time it's a vice versa from this into this format, okay? This is what you're going to have. So it means we are going to drop this exponent, which is 3. So it will be 3 log 5 base 10. Where now I can substitute in place of what? In place of this log 5 base 10, because I have got the value of this log 5 base 10 here. I'm going to substitute log 5 base 10 is 0.699. So it is going to be 3 times 0.699, just like that. Okay, so it is now you guys and your multiplication, but this is going to give you something like 2.0 0.097, 2,097. That is what you're going to obtain. Okay, so that was our A. Let's move on to our B. Our B is log 50. So if you are to cross check, we have to expand in these numbers. So this time 50 is same as what? Log 50 in base 10. So 50 is same as 5 times 10. Do you see we can use this 10, but we were not given this 10. So you see now that part that I was explaining, because this 50 here is same as log 5 times 10 like this. That is what it means in base of what? In base of 10. So you can separate this because you know that from your laws of logarithms, log mn is same as what? As log m plus log n, provided that the bases are the same. So if you're in base 10, we have to use base 10. If you're multiplying, it means you were adding. So this part, we are multiplying these numbers. So it means we were adding two logarithms here. We were adding log 5 base 10 to log 10 base 10. That is what exactly that was taking place. But I know the value of log 5 base 10 I'm given here. Log 5 base 10, that's 0.699. Okay, plus log 10 base 10 is the one that we said we have to make adjustments here, and we said log 10 base 10, that's a 1. So if we are to add this, 0.99 plus 1 is going to be 1.699. So this is your log 50, 1.699, not log 1.699, but just 1.699. There's no log there. Okay. Then let's see another part, log 1/2. What are we going to do here? Okay, so let me try to remove some of the parts here so that it can help us. Okay, so there we are given log 1/2. And actually, I just want us to know that sometimes you might not be given something that is direct. You have to make adjustment from what you are given there. Okay, let's see. Let's see what we can do here. All right, so this is C, which is log 1/2. Okay, so actually log 1/2 is the same as this. We can just write it as log 5/10. Okay, we are in base 10 like this. We can write 1/2 as 5/10. Remember, we want to write this in terms of these numbers here. 5, 10, 101. So this one is same as 5/10 like this in base 10. Because if you reduce 5 into 5 is 1, 5 into 10 is 2. So it's just one and the same thing. But this time you are dividing. So remember what made you to divide. If you're given m/n, it means you were subtracting logarithms, log of m minus log of n. So that is what you're going to have in this case. So this means you are dividing, so you were subtracting the logarithms, that is the log of 5 in base 10 minus the log of 10 in base of 10. And it's an advantage because we have got the log of 5 in base 10 here. Log 5 base 10 is 0.699 minus log 10 base 10, which is a 1. Okay, now it's not direct for us. We can't subtract these two direct. So what am I going to do? I'm going to do the opposite. I'm going to subtract 1,000 minus 0.699. Okay, so if I subtract these two, I'm going to obtain 0.310. But the answer now is supposed to have what? A negative, because I'm subtracting a bigger number from a smaller number. So my answer is going to be negative 0.310. So on your subtraction, guys, if you're still having challenges or subtracting, make sure that you watch those videos that we did previously on subtraction and so forth, so that we can catch up with others. All right, number 14, we are given, this is what we had, 2 lines from our, let's try to take it. Okay, so we had something like this. Let me just try to put it this way so that maybe it can help us. Okay, this is what we had, 2 lines that we had, and we are being given that OM is 5 units here. From O to M, we are given that is 5 units. So here from O, this is your O here. Okay, what am I doing now? All right, from O here to M, this is your O here, which we know that this is at 0 here. And M is at this point. So we're given that in between these 2 points, there are 5 units. So it means the point at M definitely will be -5 because it's in the negative region. So it's going to be a -5. If it was above the line, then it was going to be a positive, okay? And we are given the equation of line B here. The equation of line B is y is equal to half x. This one, we are given the equation y is equal to half of x plus 3. That is the equation of line B. All right, so that is what we had for the meantime. And the first question is, given that line B passes through 0t, find the coordinates of the value of t. Okay, so what is the value of t in this case here? T, if we are to cross-check, it's a point that we have on the line, on line B here. And we know that this is the y-axis where I told you guys in the y-axis, x is equal to 0. And that is what you're already given here. So if x is equal to 0, you're simply going to substitute the value of x here, which is 0, because you are given the equation of what? Of line B, which is half x plus what? Plus 3. And we are saying on this line in the y-axis, your x will be equal to 0. So it is going to be half of 0, which is 0 plus 3, which is 3. So that is the value of y at this point, which is 3. So therefore, that is the value of t, which is 3. So this is your t, sorry, t, which is 3. Okay, so here the point in the y-axis at this point is it's a 3 here. Okay, let's see another part. Write down the coordinates of M. So the coordinates of M, if you cross-checked here, I talked about this when I was explaining about this distance OM. So we know that this is minus M, but the coordinates now, how do you write the coordinates? So M as the coordinate, we are saying X here, it's a 0. So we are still in the y-axis, where I said in the y-axis, X is equal to 0, but now it is going to be like this. Now these are the coordinates, the point now like that, all right? It's now a point. Okay, let's move on to the other part of the question. If n is parallel to b, write down the equation of line n. Okay, they are saying the line n is parallel to line b, then write down the equation. Okay, this is our line n here. Okay, that is our n. And these two, they are parallel. What do we know about parallel lines? We know that they have got same gradient. That is the only thing that we know about this parallel. They've got same gradient. So here we can obtain the gradient of this line because we are given the equation of the line in the form of y is equal to mx plus c, where we know that m is the gradient here. So this half here is your gradient. So it means the gradient of line B is equal to the gradient of line N, and that gradient is 1/2. So if we have got the gradient, it is going to be easier now to find the equation of what? To find the equation of line N. Why? Because we know our equation is going to be in the form of what? Y is equal to mx plus c. So it is going to be y is equal to m, which is the gradient, and we said our gradient is 1/2. So it is going to be 1/2x plus c. Now we need the y-intercept, and the y-intercept of line N here, this is your y-intercept, where it crosses the y-axis, and it crosses the y-axis at what? At -5. So it is going to be -5 like that. So that is the equation of what? Of line N. Okay, so that's what we had, guys. Just like that, you can actually determine your equation. Okay, then on B, we are given that there is an expression which is referred to as 5x minus 5x plus 7. In this expression of 5x plus 7, write down the special name given to 5 with respect to x. Okay, this 5 here with respect to x. What is the term? What is the expression? This is a coefficient, isn't it? So that's the coefficient here. The coefficient of what? Of x. So that's the coefficient of x, this one. So we are referring to the coefficient. Okay, that is what we had. At a number which multiplies, if there's a number that is multiplying like a term, a letter, that number is the coefficient, just like that. I think it was very clear, isn't it, guys? It's clear, this one. Okay, for number 15, we are given giving the answers in base of 3, evaluate the given values in base of 3. All right, so let's try and see what you're going to have in base of 3. This is our A. Okay, for examiner's use. Okay, today we are the examiner, guys. We have to write on this page today. All right, so you are not allowed to write on this page, guys, but for me, I'm just going to put it here. All right, so let's see what we have got here. Let me put a red one or another one. Let me cross check some of these markers. Maybe they might be much nicer to use. I don't know, but we'll see them, guys, later on. Okay, let's just work with the ones that we have for now. All right, so we are saying that we got something like 1. This one is west. This one is something else. Yeah, guys, you tell me which one is the best on your comment in the comment section, so that help us to actually know. Let's just get back to our red there. Okay, so we had something like 1 1. Not 1 1, but this is 1 0 here. So we've got 1 0, 0, 1 in base of 3, minus 1 2 2. This is 1 2 2 in base of 3. Okay, so this is what you're going to have. So remember, in base of 3, if you have to subtract just as usual. 1 minus 3, it's impossible. So what are you going to do? We have to add the base, in this case, to the what? To the number that you're given. So here we are going to add the base, which is 3. So 3 plus 1, it is going to give us 4. After adding the base, we give a 1 here, so it is going to be a 3. Okay, so now we can subtract now 4 minus 2, which is 2 in base of 3. Okay, we do the same here. 0 minus 3 is impossible, so we have to do the same. Add the base, then give a 1 there. So we're going to add the base here. So if we add the base, this is going to be 4 plus 0, which is 3 plus 0, sorry, because it's just a 0 there. So it's 3 plus 0, which is 3. Then we give a 1 here. So it is going to be a 3. It was a 3 here. It was a 1. So if you give a 1, it's just going to be a 2. Okay, sorry guys, I'm now mistakenly having this. Okay, so 3 minus 3 here is going to be a 0 there. So this one is going to be a 0 here. It's the way that I've written this number, they're not in line that much. Okay, this is 0 here. Okay, anyways, here 0 minus 2 is impossible again. So we have to do the same, add the base, which is our 3. So we're adding a 3 here. 3 plus 0, that is 3. We give a 1 on the next digit, and we do not have any digit here, so we're just going to write our 1 here. So that is what you're going to have, guys. And we can subtract this part here, which is 3 minus 2, which is 1. 1 minus 1, that is a 0 here. So our answer is just going to be 1 0 2 in base of what? In base of 3. All right, so that's what we had. A family borrowed on number B. There's a family that borrowed $12,000 from a lending institution. The amount was paid back with an interest in 9 months. If the amount paid back was 12,360, calculate the interest charge. So interest charge is simply the money that you pay back minus the principal, that is your interest. Okay, so the amount that was paid back, it was $12,360 minus 12,000, which was the money that was borrowed, which is the principal amount here. So if you subtract these two, we are going to obtain what? $360. So it's dollar. A dollar is like this, 360, just 1, not 2. Don't put, you see, 1 of them. Okay. Then what is the interest rate? So the interest rate now is the percentage. That is the interest rate as a percentage So remember that interest is equal to PRT over 100. So we can use our formula here. Since we know that interest, Jesus, yes. All right, let's see here. Okay, so like I said here, we know that our interest is equivalent to PRT over 100, like this. Okay, so that is PRT over 100. So we need to calculate this rate, this one, that is the one that we need. We now have the interest. Remember, we calculated the interest here. Let's just put in our information here. Our interest, we calculated this interest here, and we said our interest is what? Is this one, which is 360. All right, so it's gonna be 360 here, which is your interest. 360 is equal to the principal. That is the amount that was invested. In this case, it was 12,000. Okay, so it's 12,000 times the rate times the time. The time here is 9 months, and time is supposed to be in years, so it's going to be 9 over 12. Okay, so that would be 9 over 12 in what? In years. Everything over 100, like that. Okay, so there we can calculate our R, which is the percentage rate. So let's play around this question, guys, and see what you're going to have. We can actually cross multiply here because this is same as like we're having over 1. So we can cross multiply the two. That will be 36000. That's a 0 here. I mean, we've got 360 here, and we've got these 2 zeros here. Okay, and here we can actually, so this is cancelled with this because we've removed. So here 12 into 12, that is 1. So you're going to be left with 1000 here times 9, which is 9,000 R. Okay, so to find the rate, we can divide by 9,000. Okay, can divide by 9,000 here. So this can cancel. So we've got the rate, which is equal to 3 zeros here. Cancel with 3 zeros, 9 and 36, which is 4. And this is percentage rate, which is going to be what? Which is going to be as a percentage like that. So that is our R as a percentage in this case. Okay, so that's what we had, guys, and it is actually 4 marks for everything on this question. Okay, for number 16, we are given in this case, this is the information that we had. List insert this information, the subset below. Okay, we are given the Venn diagram. Okay, that is what we had here on our Venn diagram. So remember, we just have to list everything properly in this case. In set P, let us cross check if there are some elements which are common here. Okay, so in set P, okay, or let me just, what can I do, guys? Because this is going to be something else. But if you are to cross check here, in set P and Q, do we have anything that is going to be on the intersection of everything? Yes, 36 here. Okay, so I'm going to just indicate this way, 36, 36, 36. This is on the intersection, okay? Let's see another part, okay? Let's cross check in A and in P and Q. Okay, in P and Q, we have got 6 here, 6 here. We have got 12, 12 here, 12 here. That is what we have in P and Q. So this is for P and Q, okay? Yeah, I think that's it. Let's cross check between P and R. Okay, so let's cross check between P and R. Let's use another one between P and R. This one, we have got 4 here. Between P and R, we have got 4. All right, is there anything? Between P and R, there's nothing so far. Okay, what are we left with? Let's cross check between Q and R. So Q and R here. Okay, Q and R, we've got another part here. Okay, let's use this one. Between Q and R, we've got what? We have got 9 and 9. That is what we have between Q and R. Okay, so these are the numbers that are just remaining. Okay, so let's list on these values. we are going to start with this 36. This 36, remember we said 36 is for all the three. Okay, so 36 is on the intersection here. That is where we are going to have our 36. Okay, so our 36 is going to be here at the intersection of everything. That is where we are going to have our 36. Okay, let's go back and refer here between P and Q. Let's start with P and Q. We said between P and Q, we have got P and Q here, we've got 6 and 6, 12 and 12. So it's 6 and 12 there, okay? So we've got 6 and 12 here. Between these two, we've got 6 and 12, okay? Let's move on to another one. We have got what? P and R. So P and R, we said we've got this 4 and this 14. Between P and R, this 4. So this 4 and this 4. That is what we have between P and R. So P and R here, we've got 4. So we are going to indicate our 4 here. Okay. Let's see another one. What do we have between Q and R? Okay, between Q and R here. Q and R, between Q and R, we've got this one in red here, this one in red, 9 and 9. So that is what we have between Q and R. We have got 9 here, so we're going to indicate our 9 here. All right. Now, what is left in P, what is left in Q, what is left in R? That is what we need. Okay, so let's start by P. Let's get back to our P. What is now left in P? So in P, we are left with 8 and 10. These two values, 8 and 10. So those are the values that you're going to write here, 8 and 10. So here we are left with 8 and 10, okay? In Q, what are we left with in Q? Let's cross-check in Q. We are left with only 15, okay? So that is a 15 that we are left with here in Q, which is a 15. Let's get back and cross-check here. In R, we are left with 25. So there we are left with 25 in R here. So this is a 25 here. Okay. Then we now need what is left outside of this sets after we've taken all these values. What is left? Okay. So you're going to see that let's just see. Okay. Let's just find a marker to indicate these values. Okay. So 4 here, 4 is taken, 4 is there. 6 is here, 8 is there, 9 9 is there, okay, 10 is there, 12 is there, 13 guys. Do we have 13 here? We do not have 13, so we are going to take this. 13 is going to remain. 15, do we have 15 here? 15, yeah, 15 is there, so 15 is taken. 25, do we have 25? We do not have. 25 is taken. Okay, so 25 is actually taken. 36 is taken. So which means it's only 13 that is going to remain outside of the set. So this is the one that we are going to have here. Sorry for this, guys. 25. So we are just going to be left with a 25 outside of this set here. It's going to be not a 13, so we said a 13, yes, a 13, okay? So that's what you're going to have. That's what we just needed here. List the elements of P intersection Q union R. Okay. So let's start with the Q union R complement. Okay. And see what does it mean here. Q union R complement. This is a Q union R complement. That is like this. Q union R complement like this. This is your Q and R. Okay, you combine this set Q and set R. The complement, which means you're going to be left with this 8, 10, and 13. That is our complement, which is 8, 10, and 13 like this. But now we are given that it must be what? An intersection with P. So intersection P. So intersection P, this is our P here. So this intersection P, our P is 8, 10, and there is 6, there is 12 here, there is 36, and there is 4 in P. So what is on the intersection, as you can see, is 8 and 10, 8 and 10 here. So we are going to be left with 8 and 10. Okay, so this noise, guys, is now too much. Okay. So this is 8 and 10 that you're going to remain with. I don't know if it is clear. So you're going to be left with 8 and 10. All right. So that's it. That's what we had in this case. Okay, then on this diagram, maybe if I'm to reduce this so that it can maybe be clear, we are given is actually a bar chart that you're given number of families and the number of children per family like this. Okay, so the question is the bar graph shows the result of a survey carried out to find the number of children per family. Write down the number of families that had 5 children. Okay, so these are the children here, number of children per family. So where we've got 5 here, this is where we've got 5 here, 5 children. Because take note, we are talking about number of what? Children per family. So 5 children here. The question is how many families? So this here corresponds with 1 here. So it is only 1 family that has got what? That has got this. That is the question, because the question is number of families that he had 5 children. So it's only 1 family in this case. Okay. The model number of children per family, the model number, remember model is the number with the highest frequency. So we are saying which one has got number, which number of children were like presented in many families. Okay, so we just take the one with the longest bar. This one 3 has got the longest bar here, which corresponds with what? With the 5 here. So that is our answer, is going to be a 3 in this case. Okay, so the model number of children is going to be a 3. Then the total number of children who were in the survey. So how are we going to calculate the total number in this case? Okay, this is what you're going to do to calculate the total number. You are saying in this family here, we have got 1, number of children is 1, and it's in 1 family. So which means we have got 1 times 1 in this case, which is going to be 1. In this one, there are number of children. There are 2 children, and there are 3 families who have got 2 children. So you're going to multiply 2 times 3. So that's what you're going to do, which is a 6 in this case. We move on to this one. There are 3 children here on this family. There are 3 children, but how many families have got this? There are 5 families with 3 children. So it is going to be 3 times 5 in this case, which is going to give us a 15. Okay, we move on to the other one. There are 4 children here, and these 4 children, they correspond to 3 families. These 4 correspond to 3. So it's going to be 4 times 3 here. 4 times 3, which is going to give us a 12. We move on to the last one. There are 5 children in 1 family. So it's going to be 5 times 1. So it's going to be 5 times 1 like this. Okay, so that's what you're going to have, guys. Then we combine these numbers. We're going to add them together. Sorry. So we are going to find something like this. If we add these together, the first one we said is 1 plus the second one, 2 times 3 gave us 6. The other one was 15. The other one, so take note, guys, we are adding this 1 here, 6 here, 3 times 5, which is 15. The other one gave us 12, and the other one 5. So we are now adding this one plus 12 plus 5 like that. Okay, so this is what you're going to have. And we obtained 39. So which means they were had a total of 39 children who were there in the survey. And that is actually how you simply find it, just like that. Okay, then we are now asked to calculate the average number of children per family. Okay, so the average number, remember, guys, average simply means what? That is your mean value. If you are given average, you are dealing with the mean value. Okay, so mean is equal to the sum over the number of terms. So it's sum of terms over number of terms. That is your mean. Sum of terms over number of terms. So the number of terms now is your frequency, the total frequency. Okay, So here, if we add everything, we obtained 39, which is our sum of terms over the number of terms. How many families were there? So that is your number of terms now. So you have to add the families. So how are you going to find the total frequency? You add these families. Here, the first one is 1. So you're going to add this one. So it is going to be 1 plus we move on here on this one. We have got this number of families. There were 3. So we are going to add 3. We move on to this one. It's 5 families. So we are going to add another family. This one, we have got 3 families here. Where we have got 4 children. There are 3 families. And the last one, it was from 1 family. So you add the families now, and this is going to give you 13 families which were in the survey. Not the children, but the families that had the children. There were 13 families. Okay, so that is the total number of children over the number of families which were in the survey. And this is going to give us the average of what? Of 3. So that was our average in this case, or oh, sorry guys, I'm writing ways. I was supposed to write it here, sorry. So this is here 13. We have to obtain 13, which is going to give us 3. Okay, so that was the average number of what? Children per family. That is where we have to divide by number of families. It's per family. So we have to divide by number of what? Families here. So this is number of families which were present. So I think by that it's much clear. Let's move on to another one. We are given number 18. Write down the next 2 terms in the sequence. So this one you have to just study the sequence here. As you can see, we are subtracting 4, 4, 4, 4, 12 minus 4, which is 8, 8 minus 4 is 8. So 0 minus 4, that is minus 4, minus 4, minus 4, which is minus 8, just like that. Okay, then study the, take note, you study the pattern. You don't just answer, you have to study first and see what is happening here. So the question is write down the value of x. So guys, what is happening here? You have to study and see what is happening here. How can we have this value of x here? What was happening? If you are to cross check here, we have got 1, 2, these numbers that are just in order 1, 2, 3, 4, 5, and 6, but here we're at 2, 8, 18. What is actually happening? It's like you are going to see that each square here multiplied to 2. Like each square, if you square this one, 1 squared times 2, it gives us 2. Okay, let's move on to this one. 2 squared times 2, 2 times 2, that is 4, 4 times 2 is 8. Do you see that is what was happening? 3 here, 3 squared times 2. 3 squared is 9. 9 times 2 is 80. So do you see that we were squaring each, then multiplying by 2? So it means here on x, for us to have this x, what are we going to do? To have this x here, we are going to square 6 as what we're doing, all these numbers. So we are going to square that and multiply to 2. That was the case here. So it means, okay, let me put it here. So that means our x here on item is going to be 6 squared times 2, and 6 squared is going to be 36. 36 times 2, which is 72. So it's 36 times 2, which is 72. All right, so that is what we had in this case. Is going to give us a 72. Okay, am I going to erase the actual thing here, guys? Guys, forgive me. This software, it needs me to be too slow. I'm too fast, and it needs me to be very, very slow. Okay, write down the value of y. Okay, so you need here the value of y here. So taking this consideration, we can actually play around like what we did for x. We can actually play around the equation to say, for us to obtain this 200, what happened? We squared this y just like what we did on 6. So it is going to be y squared like this times what? Everything we are multiplying by 2. And we are supposed to obtain what? This value, which is 200 like that. So you can formulate an equation here, divide by 2, divide by 2. So y squared is going to be 2 into 200, which is 100. Square root both sides. So y is going to be plus or minus 10. but y can't be a negative because as you can see, these values, they are positive values. So which means therefore our y is going to be a 10. So that is the value of y here, which is a 10. Okay, so that was the case. Then express z in terms of x, in terms of n. Okay, so this is z here in terms of n. So guys, this is the format that we are using before. We said each number on top here, when we square it and multiply it by 2, it gives the number which is in the below here. So it means if we square this n and multiply it to 2, it must give us what? It must give us z, just like what we were doing before. So this is our expression for what? For z in terms of n. So you can just write starting with z. So it means z is equal to 2n squared, just like that. Z is equal to 2n squared. Anything that you square here, 4 squared times 2, it gives you this. 5 squared times 2, it gives, that is the pattern. That was the what was happening in this pattern if you study it properly. So that was it, guys. Let's move on to number 19. We are given the vectors PQ. State another relationship between PQ and RS. Okay, PQ and RS, these are actually parallel vectors. Okay. So these are actually parallel vectors. Then the question is write down or calculate the modulus of PQ. So the modulus of PQ, guys, you know that the modulus is equal to the square root of x squared plus y squared. This is your x and this is your y here. So it's x squared, which is 8 squared, plus our y in this case, which is a minus 6 squared. So we are going to have the square root of 8 squared, which is 64, plus minus 6 squared. Minus 6 squared is simply minus 6 times minus 6, which is going to give us a positive 36. Okay, so this is going to give us 36 here. And if we are to have this 64 plus 36 is 100. So square root of 100 is a 10. So it's going to be 10 units. Okay, so that is the modulus, and you know that modulus is actually units. That is okay, then express RS as a column vector. So you're simply taking this from this relationship because you're already given that RS is equivalent to what? To 3 over 2 of PQ. So it's going to be 3 over 2 times vector PQ. So we can actually substitute our vector PQ, guys. Already we are given this relationship. So let's just substitute instead of wasting our time rewriting this. Let's just substitute. Okay, so we are saying that this is going to be, if we substitute this PQ, because already PQ is there, it's 8, what? It's 8 minus 6, all right? This is 8 minus 6. So that means we have to multiply 3 over 2 times 8, and as you know, guys, this is going to be 4. 4 times 2, which is 12. Okay, so this is going to be 12. Yeah, guys, this thing doesn't want me to be fast. I don't know. It wants me to write slow. Okay, so this is going to give us a 12 here. Okay, we do the same. 3 over 2 times and negative 6, like this. Okay, so 2 into negative 6, that is negative 3. Negative 3 times negative 3, which is negative 9, like that. Okay, so that is your vector RS. So we are done on this part. Given that P is a 0.69, find the coordinates of point Q now. Okay, so how can we find the coordinates of point Q? We can actually take advantage of the vector that we are given in this case, because we know this relationship that for a given vector, if I am given a vector like this here, because I'm going to take advantage of what I'm given. I've got point P and I've got Q. So here I also have vector PQ. Remember how we calculate vector PQ before. Vector PQ was obtained from what? From OQ minus OP. So we are saying OQ minus OP from the last part here, Q minus P, like that. Okay, so PQ is there. So we can actually substitute this vector PQ. Our vector PQ in this case is 8 minus 6. So it's 8 minus 6, which is equal to OQ, vector OQ. Since we want the point Q, so we are going to leave this as what? As OQ. Okay, so it is going to be vector OQ like that, minus OP. OP now, we are going to take the point P that we are given and write this as a vector 6, 9 as a column vector. So it is going to be like this. That is your OP. I think I explained this on your vectors, guys. You can watch those videos and learn from there. Let us make our OQ to be the subject of the formula here. That means it is going to be, we transpose this to the left-hand side so that it can be a positive. So it will be 8 minus 6. Now we have to add this. It was a negative here. Now we have to add it's 6, 9. And whatever that we have here is going to give us vector OQ. Okay. So let's add 8 plus 6 in this case, that is 14, minus 6 plus 9, this is minus 6 plus 9, which is simply means 9 minus 6, and is going to give us a 3 in this case. Okay, so this is our vector OQ. Okay, take note, guys. And therefore, our Q now, so therefore the point Q that we need, well, this is a vector, but we need the point Q, which is the coordinate of Q. So it is going to be 14. Take note, guys, this is 14. So it is going to be 14 as a point, and this will be 3 like this. So this is now a point from a vector. You write it as a point. So this is what they needed here. Point Q like this as a point here. So you have to write your answer properly. Okay. On number 20, we are given that there is a water tap, which can fill a drum in 10 minutes. Write down the fraction of drum that can be filled in 1 minute. Okay, guys, in 10 minutes, it can fill up the drum to the maximum. So what about in a minute? So you're simply saying, okay, this is a drum that we have got, which is a complete drum, which can be filled in 10 minutes. So what about in a minute? That is what you're simply doing, asking yourself. So in a minute is going to be 1/10 times the whole drum. So it is going to be 1/10 of the drum. So that is the one that can be filled in a minute. Okay. On B, we are now given that another tape can fill the same drum in 5 minutes. Calculate now in its lowest term or simplest term the fraction of the drum that can be filled in 1 minute when both tapes are running simultaneously. Okay, just like what we did, we are going to ask ourselves to say, in a minute, what is this tape? What part of your, guys, this is it. This is your drum here. So we are taking the full drum as 1. Okay. So when we say 1/10, we are saying it is going to take 10 parts of the drum to fill this drum. That is what I'm trying to say. So in a minute, this one, how many parts is it going to fill? That is the question now. In what? In a minute, if it takes to fill the whole drum in 5 minutes. So simply like what we did here, it is going to be 1/5. So it is going to be 1/5. But the question is, if this one can fill 1/5 in a minute, and also this one can fill 1/10 in a minute, what is the fraction of the drum now that can be filled when they run simultaneous, when both tapes are functioning simultaneous, that is at the same time? So you are going to add the first one in a minute. It can cover 1/10 of the drum. The second one, it can cover 1/5 of the drum. So we have to combine these two. So definitely, we need the LCM of these two numbers, which is 10. 10 into 10, 10 divided by 10, that is 10 times 1, which is 1, plus 10 divided by 5, which is 2, 2 times 1, which is 2. So you can add this, and it will be 3/10. So we are saying, in a minute, this is happening in a minute. When these tapes are working together, they are going to cover 3/10 of the drum, 3 parts. So which means we have divided our drum in this case into what? Into 10 parts. So that is what happened. The drum is now divided into 10 parts, and out of the 10 parts, these two can fill 3 parts in a minute together. That is what we are trying to say in this case. Okay, so don't mind these guys. Okay. Now the question is on item 3 to calculate the time that both taps, take note, both taps can fill the drum when they are running simultaneously. Okay, this is what we said. We said in a minute, these are going to cover 3 parts of the drum, which means the drum itself, it has got 10 parts. So this 10 is the full drum, or the one that when the drum is what? When the drum is full, it will be at 10 over 10, that it must be a 10. So which means 3 parts were being covered in a minute. So this is our C here. 3 parts of the drum was covered in a minute with these 2 taps. They managed to cover only 3 parts of the drum in what? In a minute. So our question is, what about when it is full? That is when we have got 10 parts of the drum. How many minutes is it going to take? So definitely 10 over 3 times a minute. And that is more here, as we can see. So it's going to be 10 over 3 times a minute, and which is going to be 3 1/3 minute. So that is what you're going to have. So depending with how your answer is written, yes, minutes. So which means your answer is needed in minutes. So it's going to be 3 1/3 minutes, or it can be 10 over 3 minutes. Do not write anything that is got seconds, because your answer is needed not in minutes there. Okay. So that's what we had. Number 21, form an equation in X and show that it reduces to. So how are you going to show, how are you going to formulate an equation? We can take advantage, guys. This is Pythagoras here. Everything is there, so you can use your Pythagoras. H squared is equal to A squared plus B squared. This is the hypotenuse here. Yeah, this is, guys, this now is too much now. Now, if this thing wants me to write slowly, guys, am I going to finish this question paper? Am I going to finish this paper now? Okay, anyways, let's see. Let me try to be disciplined enough to be slow. Okay, so H squared in this case is going to be A squared plus B squared. Okay, whereby our H is the hypotenuse in this case. So H squared, which is hypotenuse squared, is equal to, we've got the shorter sides, which is this X and this X plus 7. So it is going to be X squared plus X plus 7, everything squared. Okay, so as we can expand here, 7 squared, that is 7 times 7, which is going to give us something like 289. Or we can just start by this side, depending with what you want. So it's going to be 289 is equal to X squared plus, we have to expand these brackets here. So we're going to have 2 brackets of X plus 7 into X plus 7. So if we expand this, it's X and X here, which is X squared, X and 7, that is 7X. Then we move on to this 7 and X, which is 7X. 7 and 7, which is 49. So it is going to give us X squared plus 7, which is 14X plus 49. So this one is going to give us X squared plus 14X plus 49, like this. Okay. Let's try and collect like terms and see what you're going to have. 289 is equal to X and X here. X squared plus X squared is same as 1 plus 1, which is 2X squared. And this is just 14X plus 49 in this case. So you can transpose 289 to this side of the equation so that it can be 2X squared plus 14X. If we transpose this, is going to be 49 minus 289. So 49 minus 289, guys, what are we going to have at the end if we are to subtract these two? What are we going to have here? 49 minus 289 is going to give us a negative 240. So it will be negative 240 here, which is equal to 0. Okay, so you can divide here by 2. By 2, we can reduce everything by 2 throughout the equation. and this will be x squared 2 into 14, which is 7x. 2 into 100 minus 100, 200 is going to be 1 here, and this is be 2, and this will be a 0 here, which is going to be minus 120, like that. Okay, so as you can see, guys, we have managed to show or to have this equation, the one that we had, x squared minus and so forth. Okay, then the other parts of the equation are there. It's now you and your factorization, because this is actually paper 1, and they know that factorization can work. So let's apply our factorization, guys. On number 2 here, we're going to use factorization method. Okay, x squared, let me just write it here. What are the factors that we actually have here? X squared plus 7x minus 120 is equal to 0. So we need the factors of what? Of minus 120 in this case, factors of minus 120 that we are going to add, and they give us a 7. So in this case, I got this one's 15 and minus 8. So we're just going to have our 2 brackets here, 2 brackets x plus 15, and another bracket x minus 8 is equal to 0 here. So from one of the brackets, x plus 15 is equal to 0. So x would give us minus 15, or from the other bracket, x is going to be minus 8 on the other side, which is going to be a positive 8. Okay, so our x here will be minus 15, and on the other side, it's going to be an 8. Okay, then write down the length of QR. So the length of QR, we have to get back, and we can't use x, which is a negative this time. Okay, so QR, we have to use the positive one, which is 8. So this is your QR here, which is x plus 7. Okay, so our QR in this case is x plus 7. Okay, but we are saying the x that we are going to use is this 8 here. So it's going to be 8 plus 7, which is 15. So this will be 15 centimeters. All right. So that's what we had in this case. Okay, on number 22, we are given in this case, in the diagram, we are given QRRS adjacent of a regular, take note, these are the adjacent sides of a regular polygon with 10 sides, which means that's a if you are given 10 sides, which means are referring what to a decagon. And if this is a decagon, how is it? Because the question is, write down the geometrical name of the polygon, but it's a regular, so we have to specify that it's a regular decagon. All right, so that's what you're going to have, a regular decagon. Okay, then calculate angle PQR. PQR, this one, P to QR, this is the angle that we want here. So as you can see, guys, this is the interior angle of what? Of a regular decagon, the one with all the 10 sides on all the 10 angles being equal. So what can I do? I can simply make adjustments here to say, from this line PQ like this, if let's say we had made an extension like this, we know that this angle here will be an exterior angle. This one will be an exterior angle, and this angle inside here is going to be an interior angle. Okay, and we know that exterior angles, all exterior angles, they are going to give us 360 degrees. And it's a regular decagon with all 10 sides equal, or it means all the 10 angles are also equal here. So I'm going to just divide by 10, and I'm going to obtain 36 degrees as my exterior angle. So it means to have this interior angle, the one that I'm asked, I'm just going to subtract from 180. Why? Angles on a straight line, they add up to 180 degrees. So it's going to be 180 degrees minus 36 degrees. In this case, if we are to subtract this, it's going to be 144 degrees. Okay, so that was the interior angle here, which is 144 degrees. Okay, so that is our PQR, which is 144 degrees. Or you can use this concept, find the interior angles. We know that the interior angles are given by what? By n minus 2 times 180 degrees. whatever that you get, you divide by the number of sides, which is n, which is 10. You are going to obtain the same thing, 144. Okay. Then PRS, that is PRS, this one from P here to R here to S. This is the angle PRS from P to R to S. Okay. Which means we are referring to this angle here, PRS. Okay. That is the angle that you're supposed to calculate. Okay. There is one thing that we know about this complete angle. We know that these angles, they're equal because it's a regular what? It's a regular shape that we have, a regular polygon. So it means the whole of this angle that I'm indicating here, we already know that this is 144 degrees from this one that we calculated here, 144 degrees. But out of this 144 degrees, we are now left with this one that is in red here. So which means there's an angle that is missing, that has been removed from our angles, which is this angle here. This angle has been removed. But this angle and this angle, they are actually the same. From which concept? These sides, they are equal. So this one, it becomes what? An isosceles triangle. So if it is an isosceles triangle, we are going to calculate this angle, which is this angle, by simply subtracting the two angles from what? By simply subtracting this angle of 144 degrees from 180 degrees, then divide by 2, because we said the whole of this angle is 144. So subtract it from 180, we can obtain something like 36, yeah, if I'm not mistaken here. 36 degrees divided by 2, which is going to give us 18 degrees. Okay, so this angle is 18 degrees. Also, this angle here is 18 degrees. But we are saying the whole of this angle, it was supposed to give us 144. So to find this remaining angle here, we have to subtract 18 degrees from what? From the 144 degrees. And if we do so, this one is going to be 126 degrees. Okay, so that is the angle that we are going to have at the end here, 126 degrees. So this is 126 degrees there. All right. So that's what we had, guys. It's just a matter of playing around with the question and so forth. And on number 23, we have got express this as a single fraction. As we know, guys, to express as a single fraction, that means we have to find the LCM of these two fractions here, which is, in this case, we've got a plus 1 into a plus 2. Okay, so let's divide, guys. A plus 1 and a plus 1 will cancel, so we're going to be left with a into a plus 2. Jesus. Okay, so this is going to be a plus 2 here. If we do so, this is going to be a plus 2. Okay, minus a plus 2 and a plus 2 will cancel, so we're going to be left with a plus 1. So it's minus 3 into a plus 1, like that. Okay, so I can expand the brackets here. A times a, that is a squared. A times 2, that is 2a. Minus 3 times a, which is minus 3a. Minus 3 times minus 1, which is minus 3. And that's everything over a plus 1 here over a plus 2. Okay, so we can actually simplify further here. Collecting like terms, 2 minus 3, which is minus 1. So it is going to give us a squared minus 3, guys, minus 3 is going to be minus 1 here, isn't it? Yeah, minus 1. 2 minus 3, that is minus 1. So it's going to be minus 1a, which is minus a minus 3. Everything over a plus 1 into a plus 2. All right. So the other thing is that we have to try and see if it does factorize or not. But this one, we have factors there, 3. We do not have factors of 3, which is going to give us 1. So which means this one is done like that. Okay, it can't factorize. So we are done. Okay. Then the other part, sorry, so that there's no signature that I want to put. So there's nothing here, just pressed it by mistake. Okay. Solve the equation that is here. The best thing that we had is to express 6, and this is 6 1/4 here, 6 and 1/4. Express this 6 and 1/4 as improper fraction, multiply, then add here, multiply by 6 by, which is 24 plus 1, which is 25 over 4. Okay, so we've got 25 over 4. That is the one that we are going to take from this part. So let us rewrite this. T plus 5 squared. So this is item B. That is T plus 5 squared is equivalent to, if you have to take this value, is 25 over 4. Okay, so sorry for that. This is going to be 25 over 4 here. 25 over 4. So how are we going to simplify this part that we are given? That is the question. How are we going to remove the square? Okay. From this part, in order for us to remove the square, we have got a squared here, right? So the opposite of squared, remember guys, I told you whenever you're given a squared, we have to introduce what? We have to introduce the square root on both sides. So in this case, that's what you're going to do. Let's introduce the square root on both sides. Here, square root, here, square root. Okay, so this is gonna give us something like t plus 5, which is equal to, knowing that square root of any number is a plus or minus, so it's going to be plus or minus square root of 25, which is 5, square root of, this is a 2 there. So we can actually transpose this equation. Okay, just transpose, which means we are going to have a negative. This 5 to this side is going to be a negative 5. So t is going to be negative 5 plus or minus 5 over 2 like this. Okay, so I'm just going to separate this, which is t is going to be minus 5 plus 5 over 2, minus 5 plus 5 over 2. I'm just separating this part that has got what? That has got the plus and minus here. So we have got minus 5 plus 5 over 2. So this one is going to be 5 over 2. Or the other one is going to be t is equal to minus 5. It is going to be a minus 5 here. And this one, we now take a minus this time. So it will be minus 5 over 2. So you are now back, guys, to your fractions, your normal addition and subtraction of fractions and so forth. But if you are to, this is a whole number here. So 2 here is same as 2 and 2.5. So if we add 2.5 to minus 5, we are going to obtain what? Another minus 2. So it will be minus 2.5 so that it can actually work. So it will be, remember 2.5 and 2.5 gives us 5. So it's going to be a negative 5, a negative this one. Or t is equal to, this is actually minus 2.5. So you're simply adding minus 5 minus 2, which is minus 7.5. So remember, or you can do the longer way. Yeah, you're going to obtain the same answer though. You're going to obtain the same answer. Then on number 7, 24, we are given 24 there. These are the coins which are identical. There are 9 coins which are identical. Complete the Venn diagram in this case. Okay, so this is your Venn diagram that, sorry guys, the probability tree diagram. I'm tired now, I can see. So the question is, complete this. Okay, so there we just have to count how many $2 coins that we have. 1, 2, 3, 4, 5, and 5 plus 1, 2, 3, 4. So that is what we just need to complete here. The $2, they are 5. The $5, they are 4. And they are 4 out of what? They are 4 out of 9. So you're going to have 4 out of 9 there, because all the coins which are there, they are 9. So this one is going to be 4 over 9. So the second one is, this one is without replacement. So when you take here, we have removed 1 of the $2, so they are now 4. So here to find this is going to be 4 over 8. Or you can just subtract. You must know that each branch must give you a 1. When you add, each branch must give you a 1. So here you simply have to subtract 1 minus 4 over 8. It is 4 over 8. Here 1 minus 5 over 8, which is 3 over 8. Just like that, you can fill in your diagram. Then what is the other question? Find the probability that the total value of the 2 discs is $4. So where do we have the $4? So these are the outcomes here. You add this, $2 here plus $2. So that's our outcome, which is $4. Here is 2 and 5. Our outcome here is $7. 5 and 2, our outcome here is $7. 5 and 5, our outcome here is $10. Okay, so where is the part that has got an outcome of what? Of $4. That is the crescent. That is where we are going to take. So we're going to take this branch here, which has got this part of $4. So it's going to be this one, 5/9 and 4/8. Okay, so it's going to be 5/9 times in this case 4/8. Okay, so it's going to be 4/8. That's what you're going to have. You multiply everything and you're going to obtain 5/18. If you, because this can reduce here 2, and here it's 2, which is 4. Okay, we can reduce again. It was just a half, isn't it, guys? Just a half. Okay, then it's going to be 5/18. These calculations, you don't do them on this line here because of but you're just going to write our answer here. Okay, not to do your calculations here. Please don't do calculations there. Okay, then $10. Where do we have $10 here? That is where we've got $10 here on this part. So we are going to have the probability of $10 here, which is we have to multiply this branch that has got 10 is $5 at $5. So you multiply 4/9, just like the previous question, 4/9 times 3/8. So you can reduce this 4 into 4, that is 1. Here is 2, 3 is 1, 3 is 3. So 1 times 1 is 1/3 times 2, which is 6. Yeah, if I'm not mistaken, you're going to obtain a 6 there. Okay, then let's see another one. At least $7. Where are we going to have at least $7? So at least $7 means $7 or more. So where we've got 7 or more, that is at least 7 or more. So it's starting from $7 and more. That is what it means. So which means we are going to have these ones of $7 here, this one, and the $10 is going to be involved because it's at least, which means more. So we are going to combine these two here, this $7 and $7 here, which is, let's just take them. So we are going to have the probability of $7 plus another one. There's another one of $7 again, plus another of, plus this one of what? Of 10. Okay. Okay, this is 7, this is 7. Okay, let's start with this one, probability of $7, this one. It's this branch here, 5/9, and this one is what? 4/8. So it's 5/9 times 4/8, 5/9 times 4/8. That's what you're going to have for the first one. Plus, we move on to the other $7. This $7 here is 4/9 and 5/8. Okay, 4/9 and 5/8. 4/9 times 5/8. You combine this, and for $10 you already calculated this, so you are just taking this part that we calculated here where we obtained 1/6. So you're just going to add 1/6 in this case. Okay, already we calculated this, so you can reduce this 1/2 here, and it's going to be 5/18. Plus you do the same, here is 1, here is 2, which is going to be 5/18. Awesome. How can we write this? This is 5, guys. This is 5. How can we write this as 18, which means you can just multiply by 3 by 3. So it's going to be 3/18, since all these numbers are over 18. So this will be 3/18. So you can add 5 plus 5, which is 10. 10 plus 3, which is 13/18. Simple like that. So guys, mathematics doesn't start at all level. It starts from all those basics that we had from your Form 1 and so forth, making numbers to be the same. All these concepts, they can help you to save time in exam. Okay. Anyways, that's what we had. And let's see another part. So transformation, guys, this part is going to be difficult for me to display because I don't even know how to use a ruler on this application and to do anything here. I don't know anything. I'll see what the best I can do to work it down on a separate video. I'm going to work it down on a separate video so that it can help us. Okay, let me just add an extra one for the calculation here of this one. All right, so those are the typical questions, actually, the ones that you can obtain. So like I said, guys, I'm going to work out that question on a separate video, and I hope it is going to be clear. Yeah, let's hope I'm going to win. Okay, guys, you see now this part that what it's doing is it doing now. It's now taking a lot of time. I never thought it's going to be like this. I never thought it's going to be like this. Now it's want to convert or doing what? Okay, so what I'm going to do, guys, I think the best is to just work the rest of the questions on a separate class. So that's what we had, guys, from Meson African motifs, working on revisions, or it is now given as a separate page from what we had, and it's gonna affect. Okay, is there? Let's just do it, guys. Let's just do it. Okay, this one we're given this part, which is actually a scale. A model of a house with the outside scale is 1:500 here. So this is 1:500. So it's just a normal scale that you'll be given. And find the length of the house in meters represented by length, which is 3 centimeters on the model. So remember, guys, your similarity, I said you can change this into meters because this means 1 centimeter as to 500 centimeters. Okay, 1 centimeter as to what? As to 500 centimeters. So what it means, I can convert this to meters by dividing by 100. So it will be 1 centimeter as to 5 meters, like this. So if 1 centimeter is equal to 5 meters, what about 3 centimeters? How much am I going to obtain on the ground? I don't know. So it's going to be 3/1 times 5, which is 15 meters in this case. Okay, so this one is going to be 15 meters there. So it's a 5 here, which is going to give us 15 meters. Okay, the height of a house, 7 meters. 7 meters, calculate the height of the model in centimeters. So it's simply the same. We are going back to the same idea here because we said in a centimeter, we are going to have a representation of what? Of 5 meters. Now we have got 5 meters. So what about this one that is 7 meters? How many centimeters? So you simply have to write this under meters. So how much are you going to have? So it's 7 over 1. That's what you're going to, 7/5, sorry, this is 7/5, then multiply by 1 centimeter here. So 5 into 7, that's 0, guys, this is 1 here. This is 1, okay? Remainder 2, okay? Then into 20, which is going to be 4. So it's 1,4 centimeters, like that. Okay, so that's what you're going to have on the map. Then on 1 point, on C now, the dining room floor has got an area of 300,000 square centimeters. Find the area of the dining room of the floor model. Give your answer in square centimeters. So guys, they want the answer in square centimeters. So we have to take from our similar figures. Remember that we are given before, that is 1 as to what? 1 centimeter as to 500 centimeters. So in this case, this is your scale factor, this one. This is your scale factor. So remember, I told you that you have to square, guys, so that you can obtain the area factor. And this will be 1 square centimeter as to 500 squared. So if we multiply, guys, 500 times 500, we are going to obtain 250,000. Okay, so this is going to give us 250,000 square centimeters, which is now our area factor. Why are we leaving this in centimeters? Because that is what you are given. They want the answer in what? In square centimeter. So this is 300,000 on the what? On the map. What is it going to give us on the ground? So you're saying on the map, we can write this now as 1 square centimeter on the map equal to, so this, we are just saying it approximates to this 2. What about the one that we are given now here? Because if we are to cross check here, we are given that on the map there's an area of 300,000 square centimeters. So what is the equivalence of that now? But what is the equivalent where on the ground? I want you to take note. We are now calculating the dining room floor. Let's go this area, then find the area of the dining room floor on the model. So take note, guys, we want this on the model. Give your answer in square centimeters. So what is your model in this case? Here, this is what we have. The model is this case that we are given here. The one that we are having on a scale of this one, one as 2. This is your model here. Okay, the 500 is the actual dining room. So here we are given the area of the dining room here, and we want the area of the dining room on the model. So which means we want the one that is represented by this one, according to area. This one here is your model here. Then this is the actual value that we have on the ground. Okay, so on the actual ground, that is where we are given, in this case, 300,000. Okay, 300,000 square centimeters. Then what do we have on the model? That is the question. So we simply have to divide this. Since our answer was needed in square centimeters and we are given everything in square centimeters, these units can work to give us the exact value, because they are actually the same units. So the zeros here can cancel, this one can cancel. 5 here, that's 5. 5 into 30, that is 6. Here, this is 5 here. So 5 into 6, it is going to give us 1 comma into 10, which is 2. So it's 1,2 square centimeters. Okay, so this is what you're going to have at the end. So these are the typical questions actually on how you might be given these questions, and all that you need is to work from the information that you are given there. Okay. Then the last part of the question there, we are given now to calculate the ratio of the capacity of the module. Okay, to the what? To the actual tank. Okay, this is capacity, the ratio of capacity. So whenever you are dealing with capacity is what? It's a volume. So whenever you are dealing with the capacity, you are dealing with what? With the volume. Okay, so when they say capacity, the ratio, which means you have to find the volume factor. And I told you that volume factor is simply what? Scale factor to the exponent of 3. So our scale factor is the original one that we are given, 1:500. This is our scale factor here that we are given of the tank here, 1:500. Then we just square that. So we raise to the exponent of what? Of 3. So if we raise this to the exponent of 3, that is the ratio of the capacity, the ratio of volume. So it is going to be 1:500 times 500 times 500. That is what 500 to the exponent of 3 mean. So we are going to obtain something like 125 million if we do multiply this properly, and this is your scale factor. So that is, guys, from Mezon African motives. Let's just continue, guys, to be part of the family by also inviting others to the family, Mezon African motives, and also of all the things, don't forget, guys, to subscribe and also to share our videos, like and comment. And also the issue of online classes, like I said, guys, they are now in progress, so we can actually try by all means to register for the online classes by simply contacting this number, which is +27 618644 that's a 44 here 043, or to email, or you can just send an email, which is on the description of the channel. If you go to the about of the channel, go to the about of the channel there, you're going to see everything, the contact, the email, and everything, so that you can be able to register for your online classes if you are about to write, so that you can be, I think that can be the best for us as we are doing our revision. So guys, that's it. That's what we had for Meson African motifs. If there's any part that we didn't understand, let me know in the comment section so that we might know other ways of attempting or doing these questions in a way that can be understood by each and everyone. But for now, that's it guys, till we meet again.